Hello, welcome to Alpha Tutorial Center. In this video, we are going to talk about carbon and its compound. It is class 10 chapter in chemistry. Okay, before we know carbon and its compound, let us study a broad view of chemistry. That is, chemistry is divided into organic chemistry, physical chemistry, and inorganic chemistry. Okay, today we are going to talk about organic chemistry. Carbon and its compound is in the branch of organic chemistry, present in organic chemistry. What is organic chemistry now? Let's find out what is organic chemistry. What exactly is organic chemistry? Organic chemistry is the study of organic compound. Plants compounds that is made up of carbon and hydrogen, mainly present in plants, in animals. It is material made up of carbon and hydrogen mainly. Those compounds which are made up of hydrogen and carbon are called hydrocarbon. And this compound is also known as organic compound. And this compound occurs naturally or artificially. Okay, now let's talk about carbon, because in this video carbon will be our main hero. So we should know carbon characteristic, because we are going to talk about carbon and its compound. What is carbon and what is compound? Carbon compound. Let's now study characteristic of carbon. As we all know that carbon is group 14 element. Okay, in chapter 1 we studied that there are 7 period and 18 vertical column group. Out of them, carbon present in group 14 element. And this is the first family. In this group 14 family, carbon is the first member. You should remember that. Atomic number of carbon is 6. Okay, in SPDF, we can write carbon as 1s2, 2s2, 2p2, 1, 2, 4, 5, 6. Okay, this is the electronic configuration of carbon using SPD. Okay, 1s2, 2s2, and 2p2. Now, we know that carbon atomic number is 6. In class 10, in this level, we can also write like this, 2, 4. This is K cell, and this is L cell. Am I right? This last electron is known as valence electron, and also valency. Carbon has 4 valence electron and 4 valency. And okay, now we have this study that they occur in earth crust, mainly in earth crust. In earth crust, they contain in the forms of, we extract carbon in the forms of bicarbonate, carbonate, coal, petroleum extra, and 0.02% carbons are present in the earth crust. Okay, melting point and boiling point. The melting point of carbon, this is your home assignment. This will be your home assignment. What will be the melting point and boiling points of carbon? Is it carbon hard or is it carbon soft? Is carbon non-metal or is it carbon metal? This will be your homework. Okay, now let's talk about color. Its color is dull gray or black. Am I right? This is not so important, and it is very soft. Carbon is soft. That means you can know melting point and boiling point from this soft. And due to 4 valence electron, this one is the 4 valence electron, it can form covalent bond. It is tetravalent. It can form covalent bond, not ionic bond. This is the general characteristic of carbon. Now, we know that carbon can form covalent bond. So, in chapter 2 or chapter 3, we studied about bond, how particles are raked to each other, forming bond. So, there are 3 types of bond in this level chapter. The first one is single bond, second one is double bond, third one is triple bond. Okay, these bonds do not exist as ion but molecule. This compound always exists as molecule. This one, H2 molecule, not ions. Ions means exchange of plus ions and minus ions. But in this case, that kind of bonding is not exist, but it exists as molecule. That is covalent bond. Okay, they are insoluble in water and conductivity is very poor. Now, carbon conductivity is very poor. Now, how H2 molecule is formed? Let me write down how H2 molecule is formed now. Okay, how many H2 molecule do we have? How many hydrogen atoms do we have? We have 2 hydrogen atoms, so we can write that is 1 hydrogen, 1 hydrogen. And let us assume that this is the 1 electron of hydrogen and this is the another one. And we can also write like this. Sorry. 1 hydrogen attack another hydrogen, forming doublet. And another hydrogen also gain 1 electron from another hydrogen, and now it becomes stable, doublet now. So they are sharing 1 pairs of electrons, so the bond should be single bond. In this case, you will find that there is a double bond. And in this case, N2 molecule, you will find that triple bond. Okay, NH, not only these 3, we can also try NH, NH3, CH4 methane. You can also try this too. Okay, chân chủ này then H2 molecule form there can be double bond, there can be triple bond, there can be single bond. This is one of the, just an example. Now, let's talk about allotropes of carbon now. Next topic, that is allotropes of carbon. What is the meaning of allotropy? Allotropism or allotropes. Allotropes means the existence of two more elements in different form, having different physical properties but having similar chemical properties. Similar chemical properties na ding ay nga chu physical aki bang na. Example say ding nga chu amate ni chu diamond to graphite ka biote. And diamond he hard in graphite he soft. Diamond is hard and graphite is soft. This is hard, this is soft. Physically they are different. Okay, now another one. Diamond is have a transparent. Refractive index is very high in diamond, but in this case graphite is black in color. Refractive index will be very less. The color, even the color is not same. And now, high melting point, graphite is low melting point, tetrahedral and hexagonal. Okay, why is diamond hard? Why is diamond hard? Because of tetrahedral arrangement of particle. Because the body is rigidly, tightly packed. That's why to break this bond, the tightly particle attraction, we need a large amount of energy. So it is difficult to break easily this diamond. And in this case, graphite, due to hexagonal arrangement of particle, we can break easily. Okay, both in this diamond and graphites, both are compounds of carbon, all allotropes of carbon, because even though they have different similar physical properties, they are both made up of carbon, present in carbon. So they are allotropes of carbon. There are other allotropes of carbon, fullerenes also there. We're not going to study about that. Now, let's move to the next point, that is catenation. Okay, catenation means self-linking. Now, what exactly is catenation? Let's study now. Catenation means, in other words, we can say that unique property of carbon. Unique property of carbon. Okay, catenation means an ability of carbon to form branch chains, straight chains, or ring chains, ring shape. No? So, carbon, long chain, straight chain, branch chain, ring chains, that is cyclo between carbon atoms only, not with other element. Between carbon, let me write down. C, or C, branch chains, straight chains, branch chains. Now C. These two are same. And now let's talk about cyclo. Cyclo means having ring structure, ring shape between only carbon atom. Now, This is cyclo. Cyclo the part of ring set. And the two only between carbon atom, not with other elements. Now, why is carbon so unique than other elements? We say that carbon is our hero in this chapter, will be the hero in this chapter. So, why do we study carbon, not other element? Because carbon has so many compounds, so we study carbon based on physical as well as chemical. Why do carbon has unique properties in other elements? This is our question, and the answer can be given is that due to catenation, due to the 4 valence electron, that is tetrahedral, due to small in size. In group 14 element, carbon is the first family member. Like I say, catenation means to form long chain. Carbon has an ability to form long chain. That's why carbon is very unique. Other elements cannot form long chain, branch chain, ring chains, but carbon can form long chains, branch chains, ring chains. Okay, that's why this catenation property, carbon has this catenation. Okay, that's why carbon is very unique. Yeah, due to 4 valence electron tetrahedral. Tetrahedral means let's say now valence electron DNA. Valence electron DNA kun amay unique sa atom di sa niya. Gaining of electron, losing of electron ahin ipia form na ding zong le. Amay 4 valence electron ahi ta ja ahi amay low pd sa niya. Oh, very difficult in this case. Oh, gaining or losing of getting here. The mix size main point na siya. Main point khat hi amay. Oh, due to small in size. Carbon hi small in size hi ja chu amay unique hi this why? Group 14 element evaluation. If you look at the group 14 element, you will find that carbon is the first family member. And down the group, in class chapter 1, we say that down the group, atomic size increase. Okay, carbon, silicon, germanium will be present. Carbon is the first member, so carbon size is smaller than other element. Okay, larger the size, the covalent bond is very weak. Smaller the size, covalent bond is very strong, tightly packed. The particles or the electrons are tightly bonded. So carbon has weak ability to form a share electron, gaining electron. Okay, these 3 are the characteristic of uniqueness of carbon other than elements. Okay, hydrocarbon. Now, carbon and hydrogen together mix to form one compound. That compound is also known as hydrocarbon. Compound formed by hydrogen and carbon is called hydrocarbon. Okay. Okay. Carbon can combine with so many other elements. Now, carbon, the hero one choose his partner, that is hydrogen. Okay. Hydrogen will be carbon partner. Okay, these hydrocarbons are mainly classified into 3 types. The first one is saturated hydrocarbon, second one is unsaturated hydrocarbon, and the third one is aromatic hydrocarbon. Okay, in this aromatic hydrocarbon, we will study in class 11. That is benzene structure, whatever. No? Vast way. Aromatic. It's not easy. The class lang involved here. Preparation but in this class 10 level, we're going to talk about saturated and unsaturated only. Now, saturated hydrocarbons is, the first one is alkane. This unsaturated is mainly classified in 2 types, alkene and alkyne. Here, you can see the ANE, alkane, the first member. The first one is alkane, ALKANE, ANE. Ending with ANE, and alkene means ENE, double bond, triple, single bond. Here, alkyne, YNE means triple bond. Okay, what is the general formula of this alkane? CnH2n plus 2. But alkene, CnH2n. In case of alkyne, CnH2n minus 2. Plus 2, no plus, no minus, minus 2. See, saturated, this is how saturated and unsaturated is classified. Now, we're going to talk about saturated hydrocarbon now. Saturated hydrocarbons are carbons, that is hydrogen and carbon compound forming having a general formula of CN H2N plus 2, where N is number of carbon atom. Okay, now let's see. CN H2N plus 2. We said that N can be any number, so let's take N1. Okay, C1 H2 into N is 1. 2N means 2 into 1 plus 2. C1 means C. 2 is 2. 2 plus 2, 4. CH4. In this alkane, the first family members comes to be CH4. One carbon atoms are present with 4 hydrogen atoms. I already told you that this carbon and hydrogen will always form compound. This is known as hydrocarbon. Now, in this alkane, one carbon is present and 4 hydrogen atoms are present. When they combine, they form CH4. And this is known as methane. M-E-T-H-A-N-E. Oh, that's wrong. When carbon is 2, carbon is 2 here. C2, 2 to a 4, 4 plus 2, 6. C2, 2 to a 4, 4 plus 2, 6. C2H6. This will be your ethane. One carbon met 2 carbon at 3 carbon. What about 3 carbon? When there is this is 3. C3, 2 3 6 6 plus 2, 8. Okay, now C3H8. This will be your prop. So in the math here, 1 carbon CH4, 2 carbon C2H6 from the formula. You can derive this from the formula, and you can, when 1 carbon is present in the compound, you can say methane. When 2 carbon is present, you can say ethane. When 3 carbon is present, propane, butane, pentane, hexane, heptane, octane, nonane, decane. You should remember all this formula. Okay. Now, look this carefully. CH4, C2H6, C3H8, C4H10. When these are arranged in a systematic way, in a series, 1, 2 element, the first one and the second element were differed by CH2. And also the second one and the third one is also differed by CH2. So CH2 here's a matter niya. Differed by CH2. CH2, CH2. This arrangement is known as CH2. The difference between this one and the first one and the second one is known as homologous series. First and second CH2 as we homologous series. I can take that in my head here. To unsaturated hydrocarbon here. Okay, now before we enter into alkene and alkyne, let us first study about the alkane structure, isomers of alkane. What exactly is isomer? Now let's talk isomerism. 2 or more compounds having same molecular formula but different structure is known as isomerism. Compound ni thum hiding a molecular formula ki binding ai wanga structure ki bang lo ti kan show de to I'm going to show you now. Let's talk about C4. Okay, let's start from CH4. This is the possible structure of methane. How about the second one? C2. C2H6. This represents single bond. ANE represents single bond. I can't do. What about C3? 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen. Nah. Mo thấy nó thế nào? Là toa hay C4 là bạn tái ở xem nào. Nào. Bây giờ C4 này lung lụt tên người đó. Hot ni thum li. C4 H10 is butane. Butane. Now let's try to draw the possible structure of butane. Now, this is straight chain. When carbon arranges in this way, we call it straight chains, long chains. Okay. When carbons are arranged in this way, we call it N normal butane. Carbon can also form another structure. Can be written in another structure. Okay, let us see. Carbon, carbon, carbon. This is the possible way to write carbon. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Okay, now 3, 4 are 3, 3 are 9, 10. This is another way to write carbon. It's what about carbon hong part hen. A branch in part hen, but let's see carbon here 1, 2. Now 2 na aku carbon branch in chi ja chu 2 chu iso kiti ja. Iso kitin carbon number 1, 2, 3. And so carbon jamo 4 ipara iso butane ati oh carbon tara sin phai ne iso butane ati de ai lo wa le adang kha si ta kan so IUPAC ne mi na aji ta bi 2 methyl 1, 2, 2 branch in chine chu 2 is 2 is na le khat bi chi ja chu khat bi branch in chi ja chu methyl ati ni o ba la hen men pina kwai ding ham 2 methyl 1, 2, 3 carbon number 3 chu propane hi la ong na le chi ja chu 2 methyl propane ati ni oh it is two possible way to write C4H10, that is butane. How to draw pentane, that is C5H12. How many possible isomers are there in pentanes? Let's see. Okay, let us arrange. How many carbon do we have? Carbon number 5. Okay, 1, 2, 3, 4, 5. I write this bond because of A and E, single bond. And we have H12, 12H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, it's also N pentane there. Normal pentane there. Number 2 now is it carbon ho him. Thum lam di ko tin an ga chi so ti to so te khat ni thum li nga ai no lai no ko ja no ko ki ba chon si thai dio he okay now three, 4, 12. Right? Okay, this is another way to write pentane. Between name you have, let's name it 1, 2 isopentane. Now, I know what 1, 2, 2 branch in some carbohydrate ya chu methyl 2 methyl on the part 1, 2, 3, 4 carbon ion at part of China is here carbon history China but the carbon number 4 pemo butane 2 methyl butane what is here na adang so mala he there's another 1, 2 ne 3 na I got there carbon number 1 It's young here. possible structure card here now. So let's name this one. 1, 2, 2 9 branch in each. 1, 2 to 2. Now branch in each 2. About 2 branch in each part of dimethyl, not just methyl now. Cut both part of methyl. Branch in when there is 2 branch chains, we call it dimethyl. 2 dimethyl. How many carbon are there? 1, 2, 3 in the straight chain. Carbon number 3 means propane. 2 dimethyl propane. You have to follow in this way. Okay, other one is other C4, C6, C7, C8, C9, C10 will be your home assignment. You can practice at home. How many possible isomer are there? Okay. Alkene. Alkene, double bond. General formula CnH2n, n number of carbon atom. So, okay, can we write C1 H2 into 1? C1 H2. Okay, now in this case, how many carbon do we have? Only 1 carbon. Can there be, without 2 carbon, alkene is impossible. So, alkene will start with 2 carbon. Okay, let us keep 2 carbon. C2, 2 to 4, H4. C2H4 will be our first member in alkene. Now, what will be the name of C2H4? Do you think that this will be methane? The first member like alkane. This is not like alkane. Now, this will be named as ethene, E-N-E, ethene. Okay, in alkene family, the first member is ethene. Remember that. Okay, how to draw alkene? Let's write down. We have 2 carbon. So, 2 carbon will be formed by double bond. How many hydrogen? 4 hydrogen. 1, 2, 3, 4. Completed. 1, 2, 3, 4. Okay, this is complete. Okay, this is the way to draw ethene. Okay, now moving to the next one. Let's try to draw butene and pentene. Now, okay, now let's talk about butene. But means 4 carbon. Am I right? C4H8. C4H8 and C4H8 can be drawn like this. 1, 2, 3, 4. There are so many ways to write, 2 or 3 ways to write this butane. Because we are going to keep double bond, we should be very careful. In this case, we can keep here. Okay, let's keep the double bond in the first carbon. Okay, now we can write like this. How many hydrogen? 1, 2, 3, 4, 4 hydrogen. We have H8, so like here. 1, 2, 3, 4 completed. We have now 5, 6, 7. Now completed 1, 2, 3, 4. What about other one? Okay, completed now. See, so it's done. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Obona complete as na. Chipha the hin. It's as tan kha. Simple. Upon ska bozo lo de. Upon ska sa de. This is the one of the possible way to write structure of butene. C4H10. Okay. In short way we can write like this. CH2 double bond CH CH2 and CH3. This is the short way to write this butane. You can try another one. Okay, now let's talk about other structure, possible structure. Now C. Can we keep double bond in the second place? Okay, let's name this butane C4H8. Okay, let's count the number of carbon now. 1, 2, 3, 4. We have 4 carbon. So we should name it but. 4 carbon means but. Okay, where is the double bond? In the first carbon. So but 1 E-N-E, not A-N-E because of double bond. This is the name of this structure, but 1 E-N-E. Or 1 butene. You can write on that. 1 butene. This is the naming of this structure, that is butane. Now let's Moving to the next one. Okay. This is the way to write a C4H8 another way, another structure. Okay, this can be written in a short way, that is CH3, CH, CH, CH3. Okay, chị mình đi tiếp từ hẳn nào. 1, 2. Lại cho ấy. Bit 1, 2 na so double bond na 2 EN in it dia. Bit 2 EN in it dia. Sige. Mana number 2 na pa da ti possible structure ah. Say something. Moving to the third one, that is third structure of butane, possible structure of butane. We have completed 2. Now let's write like this. 1, 2 hydrogen. This is possible. Let us study now. It's another carbon. 1, 2, 3. 1, 2, 3, 4. 8 here. 6, 7, 8. Okay, this is also possible. Okay, now this is another way to write. This is butene. Okay, now let's start with pentene. How to draw isomers of pentene? Possible structure of pentene. Now, CH2, this is the one way of writing pentene. I already told you in the pentane, so I will be moving very fast. CH2, C2. Okay, there is a short way to write this one. CH2, CH, CH2, CH2, CH3. This double bond present in the first carbon, so 1 pentene. This is the normal pentene. Okay. Again, moving to the next one, that is the second one, CH3. We can also write like this. So in the carbon number carbon because carbon contains 5. Hey, the hydrogen H2 double bond to just I'm replacing the position of double bond. In this case, the double bond is in the first one, and in this case, second case, double bond present in the second one. So we call it this 2-pentene, cis-2-pentene. This is the short way to write pentene. Okay, now moving to the third one, pentene can also be written like this: C double bond C C. Okay, we can include H. If you include H, you will get H10 like this one, but the structure are different. But say having same chemical formula, but different structure, so they are isomerism. Okay, we have here CC. So the double bond present in the first one, and branch chain start with the second carbon, so we call it 2. Only one branch chain are there, so 2-methyl, not dimethyl, because of when we have 2 branch chains, you should name it dimethyl. We have 1 branch chain in the second carbon, so 2-methyl in double bond present in the first carbon, so methyl 1-butene. How many carbon are there? 1, 2, 3, 4. 4 butene. Now 4 carbon combination. I mean 4 carbon butene. Don't count this one in the last part. Now it's 2-methyl butene, 1-butene in. 2-methyl but 1 e bol bong wa chu 2-methyl but 2 e yang ke bol thein la chu adu bol ban pa kho hin phayal ai jing oh. It's I carbon number 1, 2, 3 na I only. So G D O 3-methyl this oh. 1, 2, 3. That's 3 na 3-methyl na carbon abana chu butene na ti de oh la so carbon hydrogen na tang
Thank you for watching this video. If you enjoyed it, please hit the like button and the bell notification icon.